Okay, welcome again to Wickerson Studios. This will be the 111th script. Very simple use of relative item and relative items, working out of the, starting with the example of the Pathmapper. So let's just grab this, shrink this down to half, bring this down to here, and let's move our Grasshopper file over. Let's get started. What we have here is basically, I'll take this and put it in shaded, and I'll show you full details what we have. I have everything here, but what we're going to do is grab everything and hit enable on and preview on everything. And now we can select what we have. So I've started with a simple grid. So it's extremely parametric. I've simplified. Didn't need to simplify the cells, but I was going to maybe do something with those. I grafted the points. So the data runs into this data structure with one item on each, 36 branches. So I can play with that. I introduced my indices. I didn't do anything to them, but I pulled out the data and put it into a split tree. And I took a series of 0, 2, 4, 6, 8, 10 whenever it ran out in this in the A branch, and the B branch 0, 2, 4, 6, 8 till it ran out. And then I took all the indices of the last one. I took the grafted points and I flattened the same points and I brought them together into a nice pattern and a nice line. Nice use of that, and you've got yourself an interesting pattern that's two-dimensional. Pretty simple, bringing a data structure that looks like this into a flattened data structure that looks like this. So that's the first example. That's not too hard to figure out. You could have no problem jumping into that. The next one, I took the same points again, and I ran them into a relative item list. And in doing so, I didn't mean to put this one in there. I basically just took relative items A and B and decided I wanted to go from 0 to 1. If you think of the pattern and think of this as 0, 1, 0, 1, 0, 0, 0, 1, 1, 0, and 1, 1. And so basically following that path with the offsets, if that doesn't make sense, I've drawn a line. So that goes from 0 to 1, starts at 0, 1, and goes to 1, 1. And that's what that line does. And then also it takes 1, 1 and goes from this point to the next point to the next point. And that's how I get the diagonals. And there's that gridded system. So you have that one on the first one, this one on the second one. Not too hard to figure out. Play around with that, and you'll get a hand of using relative index. Let's go on to the next one. I kept the point sizes. I was looking at them. Well, definitely in grafting those, we could maybe take this item out, ungroup. Didn't mean take it all out of there. Leave these in little clusters, groups, not clusters. You could make it in the clusters, but there'd be no point. I'm going to take relative items, and I'm going to play around a lot with what I can do between these points and these points, and putting a line between them and ending up with this pipe form. You can see here, if I take 1, -2, and 1 and 2 and plug them in, you can write them all into the same panel, but I don't. I could take this one and shift that one in and get those lines there. I could just get in these lines if I wanted, which is kind of boring. I could put those lines in the graft over. Not graft over, just mark them over. Those ones could come back on it. And I could always just keep adding more and more lines and grid this and have lots of two-dimensional control over what I want to have as a pattern. So there's a nice little example. One of them is repetitive. So nice little playful thing to play with relative item. Then I thought relative item, let's do it again. Let's take this one. I'm not even sure why I did it again, but I did. Let's take this one and group it. And we have our point list, which, like I said, is pretty pointless. Same pointless, kind of pointless. Actually, I think I'm just going to take off the point list. Relative items, there they are. I'm going to take this point, and this point. And I was just playing with different patterns. So exactly like I just did it. This one, I just remained the same as what I originally had. I also wanted to write out a lot of these codes and scripts. I think I maybe added a couple. No, I kept them all the same, so not really that necessary to do that. The last one I brought in two paths. So what I did was I had my original path come in as these points, and that'll be my first tree. You can see the tree from the what are they called? Displays. They're called fancy wires. So you want to definitely set up your fancy wires so you know you're dealing with a tree. Then I also lofted that with a move. Well, not loft. I raised it with a move into a series of in the z direction from a domain that goes from 0 to. And I try not to cut corners with this, but I definitely did. I should probably make a domain, plug it in here, and have my domain go from 0 to 10. That would be more appropriate, and I should technically stick in another number slider here so people know what's going on. Take this one up from 0 to 10. And then I have 6 steps that I put in to raise that one up, and you can see it's gone up in that pattern. And you can change that. You can make it match exactly 7, 5, 6, 7. And what that's going to do is going to give you the ability to do some things with this next tree pattern as long as you graphed it. Take a look at your data system. So it's coming in as a data stream AB with indices on the ends. And what I can do is take those two things and I can pull them together. Take those lines and these lines, and I can actually build lines between them and get this pretty cool pattern. And of course, that pattern follows the exact same type of logic of what I was putting on here. So if I grabbed 0, 1 only, I'm only going to get those lines that go up from this to that point to that point. But you're dealing in a three-dimensional system, which is kind of nice. So you could take that one. We could do it up by 2, which makes it kind of jog over to the right. So what I did was I took the negative alongside with that one. So if I grabbed the negative of that, I could balance back out on the other side. So there you go. And then I thought, well, it might be interesting to see what this pattern does. It kind of pulls it forward and tilts it in on an angle like that, and this one tilts it back on an angle like that. So it's a pretty cool structure as you start to build if you're a sculptor or an artist or an architect and you want to do things like this. Now you can go back in and you can play with raising and lowering those steps to make it almost look like it bends. It starts from its original and then drops down. You've got pretty good parametric control of 3D form that's been lofted and moved up and down. Not lofted, but raised and lowered. A pretty cool mechanism. If you hinged this and had this device, of course, it'd have to be springy and they'd have to be able to expand. But nice little project. Good example of relative items. You just need 2 trees, and you just keep going with it. So I hadn't spent much time on relative items, but I think that's a nice example of what you could do with it. So we'll grab all the items, see what it looks like as a group. Pretty messy, and just have fun with it. I like to always throw things into a little analysis tool because I think they look snappy. It's a little analysis tool here. Sorry, I'm just cleaning it up a bit. And I definitely want to take some things to. I think I have it already in there. There it is. It's already in on a Z map, and then I have this new one that I might want to bring in and take it to a bake. I'll put it on layer 4, group it, and there you go. You got another system of what's there. So you got one set group that you can pull over here. I think they're actually both exactly the same, but one's green and one's got the map on it. That's it. Pop it into your render. Have a look at it. Kind of nice. And pretty good control over your data structures in 3 dimensions using relative items and relative item. And that's stemming from what I was starting to think about when I was working here. Not sure what would happen. I'm just curious because I like to do things like this. Grab this item. Let's take that all off. So we're only viewing the one there. We'll pull this one back into hiding. We'll zoom into here, put it on a shaded that we can see what's going on. What would happen? Sometimes I waste my time with this because logically I have to see what I'm doing. We'll take the B's and we'll switch them up with the I's. We'll see what that does to the data structure, if anything. And there it is. It totally blasts that. And it makes sense because I've taken a pattern and started to play with the indices, stepping it up each and every one. So that's going to make a much different form than me going into here and leaving on the older path of what it was actually the indices as the final item and the B path staying as B path. So something worth playing about. You just have to keep all of your little detailed parentheses and everything in order. So you pop that one back in there, and then I think you'll see what we have. Yeah, this path there. So you can swap that out pretty nicely with just changing up your data structures, and you do an awful lot of different things to it. But I like this real controlled relative item as well. And And you can script anything you want within these masks, and you can script whatever you want within these offsets, as long as you stay with the correct form. I'd say take a look at Node Labs if that's something that you're interested in. They do some great examples of it. So there's our monstrosity. Thanks again for watching. 10 minutes.